54. Okay, so same result, but this is fine for 6 terms. But if you were asked to do the sum up to 60 terms or 600 terms, this would be a lot of work. This would be the exact same amount of work. So worth learning about what that sigma notation means and how to use our newfound formula for it. Question 7, part 2, has a mistake in it. That -8, you can see the pattern was supposed to be it's going down in minus halves, but actually it's going up in halves, but they've made a mistake with that 8 there. It should be a 9. Okay, so it should go minus 10, minus 9.5, minus 9, minus 8.5, minus 8, blah, blah, blah. Okay, so your nth term here is going to be, well, you're going up in half, so it's 0.5n plus your 0th term. So if you go back a term here, you're going to get minus 10.5. So sorry, minus 10.5. And just check that like your third term should be minus 9. So you'd say 0.5 times 3 is 1.5. Take away 10.5. That gives you minus 9.5. Okay, 4 is the 29th term. Actually, let me see if I can show you why that is. You can count them up, but maybe it's easier to say 0.5n minus 10.5 equals 4. Move that over. 0.5n is equal to 14.5, and then multiplying through by 2, n is equal to 29. So that's your 29th term there. And they have asked you in question 7 to write this series in sigma notation. So what we're saying is the sum of this pattern, 0.5n minus 10.5, for values of n between 1, our first term is minus 10, and 29 to get our last term. So that's your answer there for question 7. Finally, question 9, and this will be the last one. The third term in an arithmetic sequence is 18, and the 7th term is 30. Find the sum of the first 33 terms. Okay, well, we know that, what did we say? dn plus c is 18, d times 3, plus c. So if you remember, we were saying dn plus c is our general expression for the nth term. So that's 3d plus c is 18. This tells us that d times 7 plus c is 30. Okay, so simultaneous equations there. We have 7d plus c is 30 and 3d plus c is 18. So subtracting them gets us 4d plus 0c is equal to 12, and that d is 3. And then come back up and work out what c is. Well, that says d is now 3 times 3 plus c equals 18. 9 plus c is 18, and c is 9. Okay, so our general expression here for this pattern is the nth term will be given by 3n plus c is 9. And just check, third term, 3 times 3 plus 9, that gives 18. 7th term, 3 times 7, 21 plus 9 gives 30. Yes. What is the 33rd term? So our common difference, d, is this 3. Okay, we're going up in 3s, and you can check that out if you prefer to actually write out the first term here is going to be 3 plus 9 is 12. The second term is 6 plus 9 is 15. The next one is 9 plus 9 is 18. So you're going up in 3s, and your first term on the list is 3 times 1 plus 9 is 12. Okay, so the sum of the first 33 terms using our formula for the sum of a geometric sequence series is 33 over 2 times 33 minus 1 multiplied by our common difference of 3 plus 2 times our first term, which is 12. Okay, so how does that come out? That is 33 over 2 times 32 multiplied by 2 is 96 plus 2 times 12 is 24. And that is 33 over 2 multiplied by 120, which is 33 times 60. And 33 multiplied by 60, I'm going to need my calculator there. 1980. 1980 is the sum of the first 33 terms there. Now, I'm going to ask you now to do questions 1, 6, and 7. And in class tomorrow, we're going to do 2, 3, 4, 5, 8, 10, 11. Okay, thank you.